All right, so this is all things that you learned about in Algebra 1 class, but just to remind you that a relation is just any relationship between two things. Like your book even goes so much to talk about like non-x and y things. They're like, you can relate your height to your shoe size. Shoe size. You can relate what you had for breakfast to what you had for lunch. Right? Like you can really relate any two things. We're going to just jump straight to the x and y's because I feel like we can do that. And remember that the first value, usually call that the input, but as you advance in math, we call that the x value, right? You put in the x, you get out the y. And you could even say that x is the independent variable because that's the one you pick first. If you think about when you make an xy chart, you can pick whatever you want for x. You plug it in, and y is kind of stuck depending on what you got for x. So we say x is the independent variable, y is the output or the dependent variable. Not even just rain, like chance of severe weather for Halloween. I know. So a lot of places have like moved their Halloween to Friday night, but no one around here has. Jamestown, that's supposed to say, that's not really supposed to.
Yeah, how are you gonna move your Halloween to Friday night?
So, I know. And a lot of drug people apparently. This Hodge was at Raccoon, and she said she wouldn't even feel comfortable taking her children.
Wait, she was there? What was she doing there?
They have camper. They like to camp. I don't know.
She didn't take her children?
The funny thing is, some people that get off campy also get out alcoholic drinks to the adults.
What? That could be why she didn't want to take her children.
Well, it's not like that if the drunk people handing out the drinks.
I don't know.
Let's look at this far.
So a function, all right? This is how the book defines a function. A function from x into y is a relation that associates with each element x exactly one element of y. Let's say it weirdly, right? I wish they would just make it the way I say it, but. So every element of x goes with exactly one element of y. An easy way to think of that, and I might have had that down here that I just covered up, but x cannot repeat itself. Right? All the x's have to be different. And I throw in the words here, domain and range, which I hope maybe you are somewhat familiar with. Instead of talking about x's, we can talk about the domain, which is all the x coordinates. And instead of talking about just the y coordinates, we can call that the range. So I think I wrote that down here. To be a function, all the x values, or the domain, must be different, which is kind of the same thing I just wrote there. So a couple problems on your homework today are as simple as they give you a set of ordered pairs and they say, is it a function or not? But that's kind of baby math. What we really want to focus on is looking at equations and determining if equations are functions. So we'll do some of that in a minute. I have to write all this down. That's the bad thing about something. You can write all this.
More.
What stuff? Because there's lots of stuff there. Domain, tomorrow we're going to find domain of functions, and I feel people kind of struggle with domain sometimes, so we're just doing that tomorrow. And then the third day, we're going to add, subtract, multiply, and find functions. I feel like there's already something there. Like I could have maybe squeezed in domain today, but I feel like from my experience in pre-calculus, people struggle with domain, so I'm doing it.
This isn't pre-calculus. It's so common. Yeah.
It's pretty much college.
go home and go in and read it.
Everybody okay if I go on here? Alright. Another thing, just to remind you, and if you feel good about vertical line test, you don't have to write this down. It's not in your book though, so I just wanted to remind you that I like to think about whether something is a function. I don't necessarily graph it all, but I think about what the graph looks like. I didn't really write out the vertical line test rules because I didn't really want to write it all out. But remember, like, if you draw vertical lines on your graph, then if it's a function, no vertical line will touch that graph in more than one spot. And so if I drew just like a linear equation like this, and like when I taught pre-algebra, I would always tell students, like, imagine your pencil, right? It's a vertical line. If you took your pencil and moved it across that graph, do you agree that that pencil isn't going to touch that red line more than one spot at a time? Which means it passes the vertical line test, right? Like, none of these touch in more than one spot. So I would say, yes, it's a function. As opposed to if I had this as my equation that's graphed, if I took my pencil, oh, my pencil's not long enough, or if I drew a vertical line, that touches that graph 2 times with the same line, which means it fails the vertical line test, and we say that this is not a function. So when I look at these problems, although they're not graphed, I think about what would the graph look like would it pass the vertical line test. That's what I do a lot of times. And I'll talk to you how the book does it in a second. All right, so memories of the vertical line test. You okay back there, Nathan? You haven't broke out the Yahtzee yet, have you? Do not turn it on. I'm going to confiscate it. Okay with this? Vertical line test? Memories of this? You don't have to, as long as you have vague memories of it, right? It's just up to you. So, here are a couple problems on your homework today. It says, determine whether each relation represents a function, and they just give you some points. And how do, well, I'll let you write that before I jump ahead here. To be a function, what has to be true about the domain? All x's must be different. So if they give you something like this, all you have to do, and which one's the x, the first coordinate or the second coordinate? First one, right? So, number 1, Bryce, is number 1 a function? Because, right, if the x repeats itself, think about that fails the vertical line test because it's going to touch at x equals 2 times. No. And for number 2, Vaughn says yes. Do you agree with him? Y can repeat itself. The y could be the same number all the way across, but x can't. All the x's are different. So we say yes. Okay about that? Again, that's like 2 problems. We really care about our equations, so let's look at those. Okay? Okay with that? Stop me if you have questions. So you could just say, is it a function for directions if you don't want to write all that. That's how the book writes your homework equations for directions. If you have a pretty good idea of what these graphs look like, then it's pretty easy to tell if it's a function or not. The book says to figure out whether it's a function, you should think about when you plug in different values, are you ever going to get the same x value used twice? And you'll see in a minute that maybe there's an easy way to tell if it's a function or not a function. So like for y equals x squared, for me, I think about that's a parabola, and I think about does that pass the vertical line test? It does. Right? But the book says think about whatever value you plug in here for x, right? You're never going to get the same x value used. Or maybe think about For every y value that you think of, is the x ever going to repeat itself? And it's not. Y is going to repeat itself because you get that lovely little shape here, right? But that passes the vertical line test. All the x values are different. You don't ever repeat itself. So you don't really have to show a lot of work on this. You just get to say, yep. A lot of functions that we deal with are functions. Like almost everything that you learned about in previous classes are functions, except for conic sections. Like I feel like those are the only things that you've learned about in Algebra 2 that were not functions. Because sometimes they don't pass the vertical line test. Think about those hyperbolas and circles and ellipses. Those are kind of not good things. Which means yes is a pretty good guess, I think. Like number 4, y equals 4x plus 1. What's that going to look like if you graph it? Yeah, a line with slope. Is a line with slope going to pass the vertical line test? Yeah. Again, every x would be different. You can't think of a y value that would give you the same x value out of it. Yep. What about this one? Y squared minus 1 equals x. If you have y squared in your problem, what is that graph going to look like? Yeah, y squared, we graphed that a couple of days ago. X equals y squared. That's a parabola on its side. So if you have a y squared in your problem, to me that's a big hint that there's a problem, because that's going to look like this when you graph it in some way or the other. If you have x squared and y squared, that's also going to be a problem. It's just not going to be a parabola on its side. It might be an ellipse. It might be a circle. It might be a hyperbola. But usually this is kind of your big clue that it's not a function. Okay? So on those problems on your homework, you don't really have to show any work. It's just yes or no if you feel confident about it. Feel good about that? The only other thing we're doing today is plugging in values for functions, which you might say, why do we even need to go over this? We're going to plug in more than just numbers. So let's look at, oh my goodness, let's cover up all this craziness from here. So remember function notation. I'm not really going to spend a lot of time on this because I feel like if you've taken Algebra 2, you know this. But remember, instead of using y, when we know something's a function, we use f of x. If not f times x, that's f of x. And so then I could say find like f of 2, and that just means you plug 2 in, right? Do you have memories of this? So what we're going to do today is you're going to have a couple problems. There's only 2. Think about all the other homework so far. It's going to be really easy. You just say yes or no by looking at it. But there's a couple problems today that say find the following for each function. And they give you, look, I didn't even write function here. Let's say equals f of x here. They give you this function, f of x equals negative 2x squared plus x minus 1. And they want us to find f of 0, f of 1, f of negative x, negative f of x, f of x plus 1, f of 2x, f of x plus h.
If we get it, so do you not have
All of those. It's not that bad. We're going to do one of these together, okay? We're doing one, which is 3, 4, 5, 6, 7.
So how many of those are
2 of those on your homework. But some of those are really easy. These down here, like I want to make sure you know what this means. The number part's really easy. Come on, guys. We can handle it. We're in a college class, remember? We're college students. This is as difficult as it gets. Oh, no, let me do some of these. You can write down what you want, but I'm going to do all of them. So for A, if I do f of 0, that just means everywhere that there's an x, you replace with a 0, which means you probably aren't going to show any work on that, right? Because you could just say that's 0 plus 0. That would just give me negative 1. Can you follow me on that? Wait, are you still writing your A to G because you're complaining so much? Okay, I'll wait. I feel like you have a leg up with this whole x plus h. There's some tomorrow maybe that make you find f of x plus h minus f of x all over h. You with me on this first one? A. So if I do part B, f of 1 is the exact same thing, and I'll show my work on this one. I'm just going to plug 1 in for x. So that would be negative 2 times 1 squared, which is just 1, plus 1 minus 1. And I just work it out, and I get a number, which would happen to just be negative 2. So it's basically like giving you an ordered pair. When x is 0, y is negative 1. When x is 1, y is negative 2. So that's why we like function notation. But we can also do this with other x values, or maybe even a whole other letter altogether, like g there. C and D, I just want to make sure you understand the difference here. F of negative x, that's kind of like what we just did with talking about symmetry. We want to know, plug in negative x and see what happens. If it's an even exponent, nothing's going to change, but I'll show my work here. I would get 2 times negative x squared plus negative x minus 1. And simplify that, right? Don't leave it like that. This is going to stay the same because negative x squared is still just x squared. But that's going to be minus x minus 1. What about D? What if it says negative f of x? What do you think that means to do? If what? Yeah, it means put a negative on the outside, or change the sign of everything, right? So if I put a negative on the outside, that's just going to change the sign of everything. It's kind of like multiplying everything by negative 1. So negative f of x would give you 2x squared minus x plus 1. Going on to the next one, E, f of x plus 1, that's where you're going to have to get into a little bit more work. Everywhere you see an x, you have to replace it with x plus 1, and you do need to simplify that. So let me write this, and then I'll move my board up. F of x plus 1 would give me negative 2 times x plus 1 squared plus x plus 1 minus 1. Everybody with me on where I'm getting that? So, yeah, and so then you have to actually work it out. Like, f is easier than e here, because x plus 1 squared, remember that's not just x squared plus 1. You have to FOIL that out. That's x plus 1 times x plus 1, and times negative 2 in the front. So let's see if we could do that all at once. X times x is x squared, but I'm going to go ahead and, well, I'll just show my work here. But that would give me x squared plus x would be plus 2x plus 1. Distribute my negative 2, and I would get negative 2x squared minus 4x minus 2 plus x plus 1 minus 1. And you do need to combine like terms there. Simplify. But don't forget to FOIL that out. I think that's probably the biggest mistake that I would expect to see. But negative 2x squared, negative 4x plus 1x would be a minus 3x. 1 minus 1 is 0. So I think that's what you should get for E. And if you can do E, you can do F, because F is just plugging in 2x. And you don't even have to FOIL on that one, which makes me happier. So we would get negative 2 times 2x squared plus 2x minus 1. Sometimes I like to put parentheses around that. Biggest mistake I see on this is people multiply these 2's together before they square it. Remember, order of operations, you have to do exponents first. So don't say negative 2 times 2 squared. Right? You have to do 2x squared first, then multiply it to get negative 8x squared plus 2x minus 1. Listen for that part. F of x plus h. Same idea, only we're going to replace x plus h, which means we're going to have the f of x plus h would give me negative 2 times x plus h squared plus x plus h minus 1. Is that right? You're going to boil it out. You're just going to have x's and h's in there. Combine like terms as you can. And this leads us into eventually this section, I think tomorrow or the next day, we're going to do more with this. And I can tell you on your Unit 1 test, there is a problem with this h's in here. So again, I'm going to FOIL this. So I get x squared plus x times h times x, or x times h plus x times h is just 2x times h plus h squared. So distribute that negative, and I get negative 2x squared minus 4xh plus, nope, minus 2h squared plus x plus h minus 1. Can I put any of that together? No. That's my answer. We'll add on to that eventually. Great. I think we should do a clicker problem. Yes. That one? Do I need to show the numbers again? We don't remember our numbers, do we? Actually, I have to hold this down. But don't turn it on yet because I haven't started the class yet. I don't think. So don't turn it on. Or if you turn it on, turn it back on. So it says you're safe to turn it on. It won't let you join the class if you turn it on too early. Oh wait, that's not what I want.
Is that right? There's 2.5.
Yes. College algebra. Start class. I forgot to get our clickers, logins. No. So here we go. Here are your logins right here, starting with number 30, right? So you can go ahead and turn it on, join Dixon, enter your number in. Don't enter in Sawyer's number, Nathan. Alright, so search your class, or find class, and then see if it finds Dixon and try again. I don't know why it does that. See if this works better. Anyone else having issues with this? Say Dixon out down. So then you just have to try again. Usually if you find class and then join again, it'll let you join. Okay, everybody have their number in? So now let me see if I can start a question here. Where are we? Here. I don't find you funny. Okay, hold on. I have to start this before you can do anything. Good news is you don't have to write it down. Progress. Start this question now. Okay, so now I want you to log A, B, C, or D. Which of these is not a function? A, B, C, or D. I think you have to enter twice. So enter your answer and then make sure you want to confirm that answer, because once you hit enter the second time, you cannot change it. Lane, you haven't been in here, so you might have to go with it. But remember, I'll give you the hint. To be a function, X cannot repeat itself, or it has to pass the vertical line test. So maybe you can at least get it down to some options to guess between. He's just walked in, so I shouldn't even made him log in, but that's okay. Let's see how we are. Where we're going. Don't. Oh, still waiting. Sorry.
He's done. And it said I gotta check my answer for
If you hit enter 2 times, you can't change it. You can hit enter once and then you can still change it, but once you hit enter twice, you're locked in. So enter once and then think about it before you hit enter the second time. All right, let's see. Stop this question. All x's have to be different, right? So all the y's are the same as b, but the x's are all different. So that's a function, that's a line, that's a function. All the x's are different, that's a function. That y squared, remember, if you see y squared, that means it's not a function. So pretty good, right? Let's try another one. Oh, wait, I gotta start this one. Start this question now. Then you can write it down. So now, if f of x equals 2x squared minus 3x, find f of 3x. Found my green marker. Oh, you weren't here in first hour. I lost my green marker and like searched everywhere. It was like halfway through second period. That's why I found it. Well, I was, but then I moved it back because I lost one. I didn't think I would green marker. All right. I tried to trick you on this one. Let's see what happens. B, I believe, is the right answer because when you plug 3x in there, remember that you replace x completely with 3x. And order of operations, you have to take 3 squared first and then times 2. So that would be 2 times 9x squared or 18x squared minus 9x. B is the right answer. All right, that's all I got. Or I can stop the class and it will turn it off. Will it turn off for you, or let's check and see what happens. Stop class. It might just log you out.
End of class.
Oh, and then, so you still have to turn it off. So hold down the power button. Oh, it turned off on its own? There you go. So this is your homework, 21 through 36, multiple to 3, 37 through 39, and 42. Most of them are, is it a function or not? 27 through 37 and 38 are, is it a function? 39 and 42 are the where you have to do the A through H stuff. So you should probably be ready for 39 before you leave. Yeah, I skipped one of them because they had F of -1 and I was like, I'm not going to think. So it's got one extra. He answered for you?
Yes.
Oh, okay. On the first couple, you're supposed to, right? Like typically on the first couple, but like once you get to the equation, you don't have to. I don't really care.
You just write yes or no.
Just write yes or no. I don't care. Don't fall for it. There's only two of them there that you had to write that Bill made Raymond's kids, but I don't care. Whatever. Just say yes.
Just ask me questions.
About being slackers.
And what did you think they call it for after you saw it?
And so think about, is there anything that would ever give you the same x value twice? Do you think that that's going to happen? Like for me, like the only ones I know that aren't functions are when y squared. Like I feel like that's like the big key point of that. Like if y is squared, it's never going to be a function, ever. That's just a rational function. That's where you have those like L-shaped graphs. We'll talk about them eventually, but like that's still going to pass the vertical line test.
So why?
What's that value graph look like? So is that going to pass the vertical line test? Like I'm pretty sure as long as y squared is not in this problem, it's a function. Every time. I'm sure there's some example that's completely wrong, but no, Amber, you could use so much paper. They just worried about you and all your money that you spend on me. If you have that one, or if I missed it somewhere, but it seems like you started with day 2, and I feel like I can't find it. So I feel like you did it because you did one. What's wrong? Oh, all her paper? Yeah. She doesn't use the backside ever, first of all. Still, as long as it doesn't repeat it, it can skip it. And that's what we're talking about domains class. Like its domain is not all real numbers, but it still passes the vertical line test. Is this your homework in here? Can I count it real quick? So see how awesome I am at taking homework. Do you have that worksheet that was configured for you? Alright, we're going to say that was 25 points, so we're going to say -2 for the worksheet, -2 for that model problem, so 21 out of 25. Alright? That's how awesome it's going to be. So, I had that you were missing 1, so I'll fix that grade on you.
Like I just think there's 15 in here. They just
How about I make it 24 out of 25? They have y squared in them? Does that mean they're a function? So really that's the only time it would be a function. Or if it had, yeah, that's all I got. Because they wouldn't give you like, I was trying to think like if you solve for y, you get plus or minus, but they would never give you both the plus and the minus. So, I'm sure there's some other examples of like, we have higher powers of y besides y squared, but yeah. I say y squared. Hold on, let me write this pretty sure I've still been recording this whole time.